A minor sector of a circle of diameter 42 centimeters subtends an angle of 5/6 pi radians at the center. Calculate part A, the area of the sector. We are being told about a minor sector of a circle. Probably this is the shape. The angle here is 5/6 pi radians. A minor sector, then the diameter is 42, meaning the radius here is 21. They want area. Remember, how do you compute area of a circle? Area of a circle is given by area of a circle here will be given by I want to give this formula. I know majority are familiar with this formula, that area being given by theta over 360 pi r squared. I want to substitute it here and show you how that formula can be applied despite the fact we have 5/6 pi radians. This will be written as, our angle there is now 5/6 pi radians. Instead of saying over 360, we're going to say, you know that 360 is normally equivalent to 2 pi radians. So this one you're going to put it over 2 pi radians multiplied by, so that is like saying theta over 360 multiplied by pi, which is 22/7, by the radius, which is 21 squared. So in this context you can see the pi radian and the pi radian cancel, and once they cancel, we have now 5/6 over 2. This will become 5/12 multiplied by 22/7 by 21 squared. Let us see what we are going to get using a calculator. 5/12 being multiplied by 22/7 by 21 squared, that is going to give you 577.5 square centimeters as the answer. That is the area of the smaller circle. Part B, the length of the major segment. The length S is normally given by R times theta. So this will be, the radius is 21 multiplied by 5/6 times 22/7. This is going now to become, this will now become 21 multiplied by 110/42, which is going to become 55 centimeters. 55 centimeters. Or I show you another alternative. Let me show you alternative 2. Remember, we said 360 degrees is equivalent to 2 pi radian. What about 5/6 pi radian? Let me convert you in degrees. This will become 360 multiplied by 5/6 pi radians divided by 2 pi radian. This and this cancel. This one here once, this one here 180. So I have now 180 multiplied by 5/6. 180 times 5/6, and that will become 150 degrees. So it means, if that's what you've gotten, what it means is that you had a minor sector and we do have what's called a major sector. This minor sector, the angle here is 150 degrees. To get the outer sector here, you take 360 minus that, you get 210. Now, to get the length, remember length is given by theta over 360 2 pi r, because we want the length of the major sector. The major sector, the angle, its angle will be 210. So 210 over 360 to multiply by 2, multiply again by 22 over 7 by the radius, which is 21. When you key in 210 over 360 multiplied by 2 multiplied by 22 over 7 by 21, you are going to get 77. You're going to get 77 centimeters. 77 centimeters. 77 centimeters. This 55 was for the minor sector, but now because John was talking about the major sector, then this one here will not have been the answer. The thing that I didn't consider here was this was for the minor sector. I could have said, because the total angle should be 360, should be 2 pi radian, which is 360. The angle I should have used here, the angle I should have said 2 pi radians minus 5 over 6 pi radians. In this case, I will have remained with, when you take 2 minus 5 over 6, 2 minus 5 over 6, I should have remained with 7 over 6 pi radians. Now if I could have said 21 multiplied by 7 over 6 by 22 over 7. This now could have given you the 77 centimeters. So the answer should be 77 centimeters. This 155, remember, is for the minor sector, the length of the minor sector. But for the major sector, as per the question, it is 77 centimeters. Allow I take you now to question number B. The sector is folded to form a right circular base cone. Calculate the radius of the cone. So what you need to know that the area of the sector, the length of the sector becomes the circumference. So the length of the sector, which is a minor sector, which is 55. So that 55 should be equal to 2 pi r. And if that is the case, the length of the sector becoming the circumference of the base of the cone, so it will mean that the radius will be given by 55 over 2 pi, which evaluates to 8.75 centimeters. 8.75 centimeters. I'm using the length of the minor sector, 55, not 77, because the cone that was formed was a minor, the sector was a minor sector here. Take note of this question well. The perpendicular height of the cone. I want you to understand that the radius of the sector becomes the slant height of the cone when curved. So this means that the slant height of the cone becomes 21. So when I have a when I have something like this is 21. I found the radius, I can get the height. So height will be given by the square root of 21 squared minus 8.75 squared. And this is giving 19.1 centimeters. 19.1 centimeters.